Section 1.2, Transforming Linear Functions. Today you will transform linear functions. You will solve problems involving linear transformations. The parent function is the simplest function in the family of functions. The parent function for a line is f of x equals x, which also is the same as saying y equals x. Every linear function is a transformation of the parent function. Remember, when we graph the line y equals x, we start at 0, 0. We go up 1 over 1, down 1 over 1. So the line y equals f of x is as shown on the slide. A translation moves the graph right, left, up, or down. Transformations can also flip, stretch, or compress a graph. A general form of a linear equation is f of x equals a, which represents the slope of the line. If a is negative, the graph is flipped. H represents the horizontal translation. So if you have a plus h, it's going to move to the left, and if you have a minus, it's going to move to the right. So inside moves opposite of what you would traditionally think. And then K represents a vertical translation up or down. If you have a positive K, it moves up, and if you have a negative K, it moves down. Example number 1, at a recreation center, admission is $3 and each game costs $1. So if f of x equals x plus 3 can model the total a person spends on admission and games, let g of x be the indicated transformation of f of x if it moves vertically 2 units up. It then says write the rule for g of x in simplest form, but before we do that, we want to graph f of x on our graph. So if we start at positive 3 and we go up 1 over 1, we then can vertically translate g of x 2 different ways. We can simply look at our graph and move g of x up 2 units. So look at every point on the line f of x and translate those points up 2 units. We could also, if we want to do it mathematically, g of x, a vertical translation up means plus 2 on the outside, or where the k value goes within our function. So x plus 3 plus 2 more would give us x plus 5. So g of x equals x plus 5. What does the slope of g of x represent? Well, remember, slope is your change of y over your change of x, so we are talking about the cost for the number of games we see. What does the y-intercept of g of x represent? So the y-intercept of g of x represents the admission that we pay to get in. So the admission would be $5, and then the slope would still be $1 per game. Are there any values that do not make sense or would be ignored? Well, if we thought of negative numbers, we would want to ignore those values, because if you aren't going to go to a game and you're just getting into the recreation center, you're still going to need to pay that admission fee. So we would just disregard negative numbers. Example number 2, suppose f of x is equal to 3x plus 4 represents the temperature on a certain day, x hours after midnight. So our f of x is going to represent our temperature, and our x is going to represent our hours after midnight. So if we graph that, we start at 4, we go up 3 over 1 to graph our f of x function. They then want g of x to be the transformation of 5 units down. So 5 units down, we would represent on the outside where our k value is as minus 5. So mathematically, if we are going to write out g of x, the function g of x, we would want to subtract 5 from the outside, which leaves g of x as 3x minus 1. So then we can graph that by plotting our y-intercept at -1, and then rising 3 and always running to the right, 1. After you run to the right, you can then mirror your points to the left. So then we can begin to answer the questions. Write the rule for g of x in simplest form, we've already done. Graph both functions and compare. Okay, so you could also start by graphing f of x, and then you could have translated from f of x down 5 units, would have been another way to graph the function first and then write the equation. So when it talks about what does the slope of g of x represent, remember slope represents change in y over change in x. So if we're talking about our slope, it's the change in temperature for every hour past midnight. And in this case, the slope stays the same, 3 over 1. What does the y-intercept of g of x represent? So the y-intercept represents the temp at midnight. So what is the value of g of 3? So when we have g of 3, it's asking us what is the y value or the output of our function when we replace our x values with 3. So we do our algebra and we get 8. So 3 hours after midnight it is 8 degrees outside. Example number 3 says, let g of x be the indicated transformation of f of x, the linear function defined in the table. Write the rule for g of x if g of x is a reflection of f of x across the x-axis, and then it wants us to do a reflection of f of x across the y-axis. So I am going to go ahead and use red to represent our f of x function. So f of x, if we just plot these points, x is -2, y is 0, x is 0, y is 1, x is 2, y is 2. We can nicely see that our function, f of x, is represented by the y-intercept of +1, and our slope is up 1 over 2. So when we reflect f of x across the x-axis, I'm going to represent that with blue. The x-axis, if we reflect this point, it's 1 unit each direction, 1. So we're going to put a point here. So a reflection of f of x across the x-axis would give us y is equal to, our slope would be down 1 over 2, and our y-intercept would be negative 1. Then it said reflection of f of x across the y-axis. So if we look back at our original function f of x and we reflect it across our y-axis, our y-axis is vertical, so this point's going to stay the same. We're going to have a point over here. We're going to have a point 2 to the right. So you can count 1, 2, 3, 4, and we should have a point 1, 2, 3, 4 the other direction. So you can see that we would write y is equal to, our slope is still negative 1 over 2x, and our y-intercept is positive 1. So if we are reflecting something across the x-axis, we are going to change all of our signs from our original function, and if we are reflecting something across the y-axis, we want to change the sign of only our slope. Looking at example 4, let g of x be the indicated transformation of f of x. Write the rule for g of x, graph both functions, and compare. So if we graph f of x, we start with a y-intercept of 1. Our slope is rise 3 over 1. If we want to translate this 2 units to the left, we can count 2 units to the left from each point. Or remember, 2 units to the left is also algebraically changing our h, which would be plus 2. So g of x would represent 3 times x plus 2 plus 1, 3x plus 6. Combined our like terms, we get 3x plus 7. And you can see that our y-intercept was in fact at 7. We are still rising 3, running 1, and we just wrote the rule and compared both of those functions. If the golf team is selling t-shirts as a fundraiser, the function r of n equals 7.5n represents the team's revenue in dollars, and n is the number of t-shirts sold. The team paid $60 for the t-shirt. Write the new function p of m for the team's profit. Well, if we're selling $60 and r of n represents how much the team makes, we would take, they would still be $7.50 per shirt, but we would want to subtract our 60, so we would have $60 less. Example number 6 says, given f of x and g of x, state the translation. So if we're going from f of x to g of x and we write the equations for both functions, our y-intercept for f of x is positive 1. Our slope is rising 1, running 1. So we have 1 over 1x. For our f of x function, our g of x function, our y-intercept is at positive 5. We are rising 2, running 2, which is again 1 over 1x. And if we talk about the translation, we translated 4 units to the left. So it is a horizontal transformation, 4 units left. You now can complete your 1.2 worksheet.